You work at
Okay, page 19. So we're going to go through our quiz review.
My mother like designed them himself and then he got the wrong size. So I took them.
Okay, we're going to be going through our quiz review. I know we started yesterday with some of the word problems, but I'll try to create some more word problems for us. Now, the formulas, those are the ones that we're responsible for. The angle between vectors, I'll have that given to you on the quiz. Okay, so I'll provide that formula for you on the quiz. Okay, so let's start with number one. Draw each and label the resultant, then find the component form and magnitude of each resultant. So basically, after we create our resultant vector, we can get it into component form, and from component form, Pythagorean theorem will get us to our magnitude. And then, and then if we want to find direction, then it's not asking for direction, but if it were, we can just use inverse tangent. Okay. So we want to create vector B. So vector B is exactly as we see it, but it says minus vector A, so we have to make sure that we make vector A go the opposite direction. So we kind of map out where we're going to go. We know it's going to be up to the left, and then it's going to go down left as well. So I'll start somewhere around here. So I'm going to follow the path of vector B. So vector B is rise over run here. So I'm going to go, well, I can go left. Left 5. And then up 2, right? So I can follow that process, left 5, up 2. Okay, vector A, but now it's negative A. So instead of going right 2 up 3, I'm going to go down 3 over 2, right? Okay, any questions so far? Okay, your resultant vector is just from your starting location to your destination. And then just have to figure out the horizontal and vertical component of your new resultant vector. And that will be your component form. And then from there, you can get to the magnitude of, because now we don't care about the 2 initial vectors anymore. We only care about the new resultant vector. So to get from here to here, I'm going to have to go left 7 units and down 1 unit, right? So left 7, down 1. This is my component form for my resultant vector. magnitude, Pythagorean theorem, right? Square root of a squared plus b squared. Okay, either form is fine, root 50, or you can break it down to 5 root 2, make the calculator do that for you. Okay, are we comfortable with this process here? Okay, try number 2. We have vector 2a plus b, so we want to take vector a and we want to double the size and the length of vector a. So we know we're going to have to go up to the right, and then we have to go further up to the left. So I'm going to start close to the bottom here. So vector A is over 2, up 3. So I'm going to have to go over 4, up 6, right? So, or I can just go A twice. So up 2 over 3, another up 2 over 3. Sorry, over 2, up 3. Again, we only creating component form and magnitude for the resultant. We don't really care about the original vectors anymore now that we have the new one in play. So left 1. Okay, questions? Okay, we're going to skip the next 2. You're not going to have to draw a vector diagram free form like this. Okay. All right, so try 5 through 7. Remember, to get from ordered pair to component form, we're just going to do x2 minus x1 to get the horizontal component, and then y2 minus y1 to get to the vertical component, right? x1, y1 being the initial point, and then x2, y2 being the terminal or the ending point. And it says that the initial point and terminal point is going to be in alphabetical order. So in this case, A is the initial and B is the terminal. C is the initial, D is the terminal, S is the initial, T is the terminal. Okay. So we're just going to get it into component form. We're going to practice getting it into unit vectors. So that means we're just going to get it in terms of the horizontal component times I plus the vertical component times J. And then we're also going to find the magnitude and direction of the resultant vector. Component form, sum of unit vectors, magnitude, okay, direction. We also make the decision though, right? Which quadrant are we looking at here? Quadrant, say again? 4, yep. So quadrant 4, we got to involve what? 360, yeah. Okay, how do you feel about that process? Okay, finish off with 6 and 7 as well. Go ahead. Again, when you're dealing with your magnitude and your direction, you're not looking at your original vectors anymore, or original or pair. You're looking at your new vector, right? Only thing we care about here. Okay, check number 6. And then try number 7. Okay, any questions 5 through 7? Let me know. Question, yeah. Just leave it in square root of. Okay. If no questions, let's go ahead and go into page 20. 8 and 9, 8 A and B are pretty straightforward, right? You're just distributing the coefficient through and then adding or subtracting the vectors. Okay. Okay, does anybody still need to look at this page? Good. Number 8. Okay. A and B, pretty straightforward. You just distribute any coefficient that needs to be distributed to the original vectors. Okay, part C says, are any of the vectors orthogonal? So orthogonal means dot product is equal to what? 0, right? So I'm just going to test all the dot products here. So I'll do dot product of U and V. I'll do dot product of U and W. And I'll do the dot product of V and W, right? So those are all the options. Again, orthogonal means that two vectors are perpendicular, right? So if it's not equal to 0, that means we know it's not perpendicular. Okay, part D, if the vectors are not orthogonal, use cosine theta for vectors u and v to find the angle between each pair of vectors. So we're just going to do, we'll just do u and v. I know it's kind of implying to do all of the possibilities, but we're just going to do u and v here for part D. So again, to find the angle, we're going to be doing a couple of operations, right? So the numerator is going to be the dot product, and the denominator, you're going to find the magnitudes separately, but then you're going to multiply the two magnitudes together. You get a fractional value and involve inverse cosine to get to that theta measure. We already found it, but I'm just going to show the work here. It's only a small degree difference between these two vectors. Okay, we started 9 through 11, right? And this is, if you're given magnitude and theta, you can dump it directly into this formula, which is a shorthand shortcut, was a shortcut rather than having to draw a triangle and figuring out sine, SOHCAHTOA, sine, and cosine. So we did number 9, see if we can try 10 and 11. Go ahead. All right, any questions with 9, 10, or 11? Okay, let me review number 12 again. So we talked about how we can create two separate vectors based off of each of the sentences. Boat is traveling west at 25 miles per hour. We can create a vector out of that because 25 miles per hour west is negative 25 and vertical component 0. Current is moving south at 3 miles per hour. We can create a vector for that, separate it into vertical component and horizontal component. That means it's not moving east or west, it's just moving south. So we associate south with -3. And now it says, what's the boat's resultant speed? So we have to create the resultant vector first. So we have to add the two vectors together to kind of get an idea where the boat is actually moving because of the two forces that is being combined together. So we added two vectors together. So -25 plus 0 is -25. 0 minus 3 is -3. So now we only care about this resultant vector. Okay, the initial vectors are not going to play a role anymore. So based off of the resultant vector, we're going to find the speed. So speed is just magnitude. So Pythagorean theorem, square root of a squared plus b squared. And then direction is how we involve inverse tangent. But again, keep in mind that you're paying attention to where that vector is headed towards. Is it pointing in the first, second, third, or fourth quadrant? And that's going to help you determine whether you need to do anything to your initial reference angle. Do you have to add 180? Do you have to involve 360? In this case, -25, -3, this is clearly in the third quadrant. So we have to add 180 to that measure. We have to make sure that our theta is actually consistent with third quadrant value, and it is. 186 is greater than 180, between 180 and 270. Okay. Okay, we went through number 12 already yesterday. Any questions? Okay, 13. We do need to change the wording on 13. It says Alvin pulls a sled through the snow with a force of 50 newtons at an angle of 35 degrees with the horizontal. Find not the magnitude of the force. We already kind of have that already. Find the horizontal vertical components. Okay, so this is basically your force. That's it. That's your resultant. That's your magnitude, basically. That's the hypotenuse. And then this is basically your angle measure, right? So very similar to number 9 through 11, where we're just dumping into this formula here. Hypotenuse times cosine theta, and the hypotenuse times sine theta. Okay, let's get to decimal values. These are not going to be nice unit circle values here. Okay. Draw and label a vector with magnitude 15 meters per second at the direction of 230 degrees. And pretty straightforward, I think. We're just going to make sure that whatever magnitude we draw, we just call it 15 meters, and then the direction, it's going to be in the third quadrant, right? I know it's not asking for it, but let's just get that extra practice of also putting it in component form. Okay, go ahead.
Is there anything else I need?
No, we're just gonna do some more practice problems, but you can.
Okay.
Go ahead. Okay, any questions with this worksheet? Okay, I'd like for us to do a few more word problems, so I'm gonna create them. If you guys can just find any open space, either in your packet or in a separate sheet of paper, I'm gonna write the problem down and show it in a second. Let me write it down. Okay, so we'll call this number 15. Yeah. Okay. So treat this like how we did number 12, right? Create two vectors, then add them together to get that resultant vector. And then component form. Oh, sorry. Once you get to that component form of the resultant vector, then magnitude and direction. Okay, check your answer. I have one more for us.
How did you know that like A over B was 1 over negative 1.5 instead of 1.5 over 1?
Because inverse tangents is always going to be B over A.
How do you know if it's 1 over 1.5 or 1.5 over 1?
Because that's my y and that's my x.
Oh.
Y over x.
Mr. Yang, what are you doing? Is quarter one plus 90 or is it also plus 180
Say it again?
at the end? Because so quarter two and quarter three is plus 180, right?
Right, but because my angle measure is negative, it ends up being subtracting from 180.
Oh, yeah.
180 minus, right? Essentially, if you put the correct sign in, it'll either be positive or negative, and depending whether it should be in the quadrant 3 or quadrant 2. 180 with a negative or 180 with a positive.
Was
It
it,
should work out.
if it was quarter one, would it still be?
Oh yeah, because yeah, if it's quadrant 1, this would have worked out to be a positive because there shouldn't be any negatives showing up here.
So it's only in quarter four when it's different, when you're taking or adding to the 360, right?
Quadrant 2, quadrant 3, quadrant 4 have to involve either 180 or 360. Quadrant 2 and 3 is 180. Quadrant 4 is 360.
Yeah.
Okay, I have one more for us. Go ahead. Okay, does anybody still need to look at number 15? Okay, here's 16. Similar process. Break your two vectors into component form, add them together, and then do your magnitude and then direction. Okay, but the challenge here is that we're going to have to create the component form for vector 1 because vector 1 is not at a north, south, east, or west, right? So we have to get it into component form for vector 1. So we have to involve what we did if you're given magnitude and direction, right? Get into component form. Right? So hypotenuse times cosine theta, and then hypotenuse times sine theta.
Negative percentage. Because x1, x2 minus x1.
Well, here we don't do x2 minus x1 because we're not dealing with ordered pairs.
Oh.
We're dealing with vectors. So when we do the vectors, we're going to add them. Yeah. But if you're given two ordered pairs, you want to create the vector, then we do x2 minus x1, y2 minus y1. No need to adjust. You look at both your component form, these are both positive, so that's going to end up in the first quadrant. Whatever you get for your theta is going to be your direction. Guys, I need to check a few things here. If you can show me page 13 onward, page 13 until the end of the packet. I know it's been a couple days since I checked it. I'll have a help session tomorrow during fourth period. I'm working on a review sheet. So I'll post that up this afternoon and I'll send a reminder so you guys can work on that worksheet, or you can show up tomorrow, fourth period, to go through the worksheet in class.
I have a college visit tomorrow, so when can I make it?
All day.
gonna send them up to you?
Yes, it does.
What? You gotta pop it. No, he was calling you.
Guys, I'll take the rest of you guys.
I'm pushing this idea. This is.
Have a great day, guys. Study for your credits. I'll send out a reminder today. And memorize these formulas, except for this one. I'll give you the angle one. Thank you.
Thank you.
All right, thank you. Good
I did it. Every day,
day. Have a good day. See ya.
I'm a little confused on how you got this problem.
So the negative 25, 0 is the, so we have to think of west is left, east is right. Or west is negative, east is positive. North is positive and south is negative. So the boat is traveling west. So we can create a vector just for that boat. It's trying to attempt to go negative 25, 0.
Okay.
The current is another vector. It's moving south at 3 miles per hour. So it doesn't move left. Have a good day. It's not moving left or right, but it is going south in the issue.
All right.
And then basically when the two forces are acting together, the resultant vector is going to be what happens with the boat in actuality, right? The boat's going this way, but it's being pushed south, so it's going to kind of go in this direction. So we're going to add the two vectors together. So we get negative 25 and negative 3. So negative 25 plus 0, and 0 minus 3 is negative 3. And then from here, you're just going to build your speed and your magnitude just from that resultant vector.
Okay.
Okay?
All right.
Thank you.
Mhm.